Okay, so now let's look at an example that when we say one-sided, we are interested, like, how can we choose that if we want to go with the like mu greater than some number, or the mu like less than some number. So in this example, as you see, is a soft drink beverage company purchased 300 milliliter bottles from a glass company. It's important to ensure that the bottles meet the minimum internal pressure or bursting strength of the 200 psi. So we want to make sure that we are going to match this minimum internal pressure of the 200 psi. So our null hypothesis means that no effect. So what do? We say that our mu null is going to be equal to that 200 psi. One way that we can look at it, we can say that, okay, so let's say we said that that's the minimum internal pressure, right? So let's say the alternative hypothesis, our mu is going to be greater than the 200 psi. And if H null, if we reject the mu null is equal to 200 psi, so if we reject it, in that case, the bottles are okay because the H1 is not, H1 says that mu is greater than 200 psi. So if H null not rejected, bottles should not be used, right? So forces bottle manufacturers to demonstrate that bottles are okay. So that's one way of looking at it. Another way is that we can either say this one, or we can say, let me just see what happened here. Sorry. Okay. Another way is that when we say that, okay, so mu null is equal to the 200 psi, but mu is less than 200 psi. So this is very different than the first way that we had. So in the second way that we defined it, is like that we would say bottles are okay unless H null is rejected. So bottles are all the time okay unless they're we would reject the H null. And generally we can say that, so we can define any of these two ways. It depends that what's your standing point. We would say the first one, that mu is greater than 200 psi for the H1, is appropriate if we have had trouble with the supplier. So there is some probability that the null hypothesis is not rejected, even though true mean pressure is greater than 200 psi. And then the second one is appropriate. We were generally happy with the bottle suppliers, and a small deviation, we had a small deviation below the 200 psi that we had issue with them. So the small deviation from below the 200 psi wouldn't be that much serious. So we didn't have that many of them, right? So we would have, okay, we would say, okay, so if we just have a little less than 200 psi, that would be fine. So that's the, so when we want to define, like, if our alternative hypothesis, it depends on that, what's your standing point? So you are a customer, you are a person who would check the safety, and you're a person who would, you're an investor in this situation. So for different experiments, we would define a different alternative hypothesis depending on the situation that we have. And in some books, we are using Montgomery methods in all of our like stats analysis. So in Montgomery, the way that he explained and considered these things is that he said that, okay, so let's say that when we have the critical value for the null hypothesis, we would consider it as the equality sign. But you will see that in some books, they would say that the mu null, for example, if the alternative hypothesis is greater than 200, they would say the mu null is less than 200. And when you consider this one less than 200, you will see that the result is going to be the same. The only thing is that if we have, I would agree with the Montgomery as well, but you will see that there are people that they have different opinion. And it's a statistics, like it's data analyst, so you can have different opinion on when you're analyzing your data. In my opinion, this one makes more sense as well, because the critical point is important for you. If I would say that I'm looking for the minimum internal pressure that is like greater than 200, like minimum would be 200, so I'm looking for the greater than 200. If the situation is in a way that I'm looking for the one-sided and the minimum is important for me, like I'm like on this, I want to go with the first one, it doesn't matter for me that the mu is like 100 or not. So it's like that the important thing for me is that the mu is greater than 200. Or I mean, if I'm standing in a point that the mu, I want to define it in a way that the mu is less than 200, in that case, it doesn't matter for me that the mu is 300. Like if I was working on the second, I would consider the second part. So because of that, I think it's better when we define the null hypothesis as an equality sign as well. But as I said, we have books like, there are few stats books that they consider this one as the inequality, like the mu null as an inequality. But in our course, we consider the mu null all the time the equality sign. Okay, so the next thing that we want to learn, we want to have a general steps for the hypothesis test when we do the calculation, that you will see that in the next video.